I designed a plastic bead, made an injection mold for it, and manufactured all these parts myself to build this beaded curtain. And this project was made possible with CNC machining from JLC, who sponsored this project. Most plastic products we use every day are injection molded, but we rarely think about how those parts are actually made. So for this project, I wanted to go through the entire process myself, from designing a single part to making a mold and manufacturing the final product. The idea was to make a beaded curtain for this doorway, but instead of buying ready-made beads, I decided to design and manufacture my own beads. First, I designed the layout to see how it would look, how dense the curtain should be, and roughly how many beads I would need before starting the actual part design. Then, I started designing the bead itself. Designing for injection molding is not just about part. You also have to think about how the part will come out of the mold. That means thinking about the draft angles, wall thickness, clearances, and how the part will be released from the mold. I decided to use polypropylene because it's easy to process and works well with my small hand injection molding machine. Polypropylene is also one of the most commonly used plastic in everyday products. Plastics are petroleum-based materials, and we often hear about plastic pollution and environmental problems related to plastic waste. So making new plastic part might sound like contributing more to the problem, but materials like polypropylene can actually be melted and reused multiple times. A lot of the material I am using here comes from leftover plastic, scrap material, and failed injection molded part that can be remelted and molded again. So instead of plastic being a one-time use material, in small-scale projects like this, it can actually be reused multiple times. Understanding how materials are processed, reused, and manufactured is also an important part of product design. After designing the bead, I 3D printed a few samples first to see how they look and feel. One thing I avoided was having a flat surface along the whole axis, because when the beads line up on a string, that wouldn't look very good visually. I also decided not to use a separate pin for the bead hole. Instead, I designed a 4mm hole with about 5 degrees of draft so the part would be strong enough and also easy to remove from the mold. Once the part was finalized, the next step was designing the mold. And this is where injection molding becomes very different from 3D printing. You cannot just design the part, you design different features on the mold. This mold is a simple two-part mold with two cavities. To create the cavity, I used a Boolean operation, basically creating a block around the part and subtracting the part from it to form the mold cavity. Normally for a simple part like this method is enough. But for complex parts, we definitely can't get away with this alone. But today is our lucky day because this part is simple enough to make a mold like this. I didn't compensate for plastic shrinkage here because this isn't a critical dimension part. It's just a bead for a curtain. But if this were a functional part that had to fit with other components, shrinkage compensation would definitely be important. For a small hand injection molding setup and polypropylene parts, aluminum is actually a very good option. It machines faster, costs less, and is perfectly suitable for this kind of production. Also, this isn't a high precision production mold. The machining here is done with standard CNC tolerances, not mold grade precision. So I had to design this as a CNC machine part that functions like a mold rather than relying on extremely tight tolerances from the machining process itself. CNC services like this don't automatically make a mold. They machine exactly what you design. So the responsibility of making it work as a mold is entirely in the design. And that's what makes this interesting. You can take a relatively simple CNC machine part and turn it into a functional injection mold. Once the mold was machined, it was time to start molding parts. I'm using a small hand injection molding machine that can mold around 15 grams of polypropylene per shot. I also connected this REXC100 digital temperature controller for temperature regulation so the plastic melts consistently. Then I started molding the beads. And after a lot of repetitive molding, I finally had a pile of beads ready for the curtain. The next step was making the bead strings and assembling the curtain. So this project started with designing a single bead, verifying with the 3D print, then designing a mold, machining the mold, injection molding the parts, and finally assembling the curtain. This was basically a small-scale version of how plastic products are manufactured, going from design to tooling to mass production. We usually think manufacturing only happens in big factories, but projects like this show that even small-scale manufacturing is more accessible than most people think. From a single CAD model to hundreds of parts, this is basically small-scale manufacturing.